Hello, welcome back to my channel. Today we have a graphics card which is an RX470 4 gig. Actually, I don't know where it came from. I found it in my stash and I believe it's broken. Because why would it be there if it weren't? Let's disassemble the card first. After this one, the back plate and the shroud come off. Yeah. Let's unplug the fans. I'm trying to hold it still, not to bend the card while unscrewing. Yeah, and the cooler is out. Thermal paste, it's dry and it wasn't enough in the first place. But whatever. Normally this card probably has some LEDs. Yeah, here. It's for the LEDs. Sapphire logo probably lights up. But the connector is broken already. What do we have here? The thermal pads aren't thermal pads anymore. This is something like sticky. Man, this is too thin to be a thermal pad. I don't think these are thermal pads. And this is this the almost gone. Let me check the resistances first. And I want to check the 12-volt line in diode mode because I see some flux residue here. I don't know whether it's flux or not, but I want to check it first. Let's see. Is it shorted? No, it's not. I'm surprised actually. It should be 12 volts in, isn't it? I don't know. Let's see. 5 volts. This should be ground, yeah. 12 volt from the socket, yeah. It's shorted. we have a short on the 12-volt rail. As we can see, is the fuse popped? Let's see. Yeah, the fuse is open circuit. The fuse is popped. And let's see. This one connects to the 12-volt from D. Oh, now I see. This doesn't belong here. This is something. Someone tried to put a different DR MOS in this place. What? Oh my god. Oh my god. Does this one connect here? No, it doesn't. This one connects to this slot. Does it? No, this one is connected to the external power. Only this one is connected to the socket. Okay. This should go. This shouldn't be there in the first place. I don't know what the previous owner or whoever tried to fix this card was thinking. But this shouldn't be here. Okay, let's get rid of it first. And probably this Diamos is also gone. Let's take them both out. Some hot air. Let me apply some flux first. And I'm going to change my soldering tip. Okay. This takes some time because of the inductor here. It soaks a lot of heat. Okay. Both are out. Let's check for a short again. From the slot, do we have a short? No, we don't. From the external 12 volts, we don't. This should be 12 volt in. This one should be ground. Okay, okay, okay. So let's see the memory resistance. 30 ohms. Is this Hynix? It's LPDA. Okay, 30 ohms is alright. This is pack 17 is on point. Let's try to check the core. 0.7. That's the resistance of my multimeter. 0.3 ohms is probably alright for the core. Yeah. It should be around 0.3 to 1 ohm. Okay. How do I have these MOSFETs? I believe these DR MOSFETs are from Infineon. Let's see. 3553M. Yeah. I should have some donor boards for this one. Let me check. Yeah. I found a donor. We need to let's check for the shorts first. Maybe we have a short on this card also. Do we have a short? Not on this rail. Not on this rail. Let's see. These two are looking alright. I'm gonna take this two. One of them is out. Let's take the other one. Yeah. Let's get our car back and prep the pads for the soldering job. Get this. Someone actually butchered this card. This card went through a butcher's hand. Let's apply some flux first. I'm going to use some leather solder to prep the pads. It should be easier this way. I'm going to apply some more flux. Some leather solder. Actually, a lot of solder already here. I'm going to wick some of it. Now we should be able to solder. Oh, okay. We have 3 here. One of them is shorted. Let me show you how to find the shorted one. There are 3 big pads, as you can see. One of them is ground and one of them is 12 volts. In diode mode, I'm going to touch them. This one is okay. Let's see. This one is also okay. This one should be the shorted one. No, it's not. This one is shorted from the input to the output. The others are not. From the input to the output, yeah. This one is not shorted. Yeah. We see a diode value. A voltage drop. Okay. The other way around, we should see a voltage drop. Yeah, we see. Okay, these two are alright, and this one is garbage. Board is prepped. Let's solder the mosses. That's all done. Let's clean the excess solder. It looks alright. Let's check for a short again. We don't have a short on the 12 volts from the slot. Do we have a short here? No. Oh, I just noticed someone soldered some wires to short the broken fuses. We can do the same, but I believe these MOSFETs are going to blow again. Let me tell you why. Probably controller is that, and it's common for this model. And because the controller is that, it's going to blow the MOSFETs again, probably. This cap looks a little off the place. Let me change that. This might be the bootstrap capacitor. I don't know. If it's so, it can cause some problems. Let me quickly fix it. Okay, it's in place now. So we are still not ready to power on this card. I'm going to solder a tiny wire on this fuse. Normally I would change it, but because I believe it's going to explode again, I'm going to use a thin copper wire as a fuse. It can melt and act as a fuse if needed. Some flux, some solder. Some thin wire. Okay. Let's check if it's continuous or not. Yeah, it's continuous from the slot to the diamos. Yeah, it's continuous. Do we have a short? No. We have a short on 3.3. Let me check. We have a short on 3.3. No, we don't. Okay. Let's power the card up and see how it behaves. Are we going to see some fuses popping? the armos is blowing up. If you're waiting for me to do the same mistake, I'm sorry, I won't. Let's connect the buzzer, the motherboard. Let's wait for the card to cool down, and I'm going to come back after it's ready to power on. Okay, the card is plugged in now. I double check the PCI connectors, as we always should do. So let me turn the motherboard on. Let's turn the PSU on first. And the motherboard is on. Do we have Vico? Oh. We have a picture. Oh. Let me show you. Oh, it's hot. Let me turn off the computer. Okay. I need a cooler. And I'm going to do a quick memory test to see how the card behaves under load. Whether the MOSFETs are going to blow up or not. Let's see. But this is a good sign. I put a cooler on the GPU and PSU on. Let's turn the motherboard on. It's booting. But we don't have a picture this time. Let me check the VCore again. We have VCore. It's a little high. Higher than it should be actually. .15. It's not little, but it's high. Normally it should be around 0.8, 0.9. 0.9 during the boot and 0.8 after the initialization, but we have 1.14 here, and probably the controller is the culprit here. Not probably, I can say 99.9% the controller is bad. But let's try it again. Okay, the chip is not hot. Wasn't the thermal shutdown. So let's turn the motherboard on again. And see whether we are going to have a picture or not. Okay, we don't have a picture. Actually, let me check the packs this time. Let's check the packs rail. 1.70, 17. Oh, I think the problem is with my multimeter. Let me show you. I'm going to check the BIOS battery and it shows 3.85. This is too high. Oh, we have a picture actually. Okay. My multimeter is pulling some jokes on me. Okay, the picture is gone. Okay, it's now measuring all right. Let me check the BIOS battery. It's not all right again. It was just fine 10 seconds ago. And it's not fine. Okay, we have a picture. The computer rebooted. I don't know why. So let's reset. Do we also have a memory problem or something like that? I don't know. Now we don't have a picture. Last time we had a picture. So what I'm gonna do is I'm going to turn off the computer and get a display out from the motherboard. I also can't get a display from the motherboard. Oh, I had a bad connection. What's going on here? Okay, I have a problem with my motherboard actually. Let me fix it and I'm going to come back. I need to cut here to do some explanation. My HDMI converter was the culprit. I needed to get rid of it, and that's why I needed to use the VGA directly from the iGPU. I couldn't get a picture from the graphics card because the graphics card has no VGA output, but the tests are done on the graphics card using the VGA port from the motherboard. I needed to do this because I forgot to mention it in the video. Let's go. Okay, now I'm going to use the integrated graphics for the picture, but the graphics card is connected to the PCI slot. Okay, let's see. And I am going to run a T-server test. Computer shut down by itself. Let's check. Do we still have eco? T server. Okay. Yeah, we still have eco. No problem there. The card is running. What was that? Let me check. It's an RX470. If the camera focuses. Yeah, it's an RX474 gig. Let's see. Okay, the test is about to start. Okay, I saw the pass. Yeah, this is a pass. No errors on the memory. Yeah, as you can see. I'm going to shut it down, but okay. I said but and then stopped. Let me tell you why. Because this is a memory test and it doesn't fully take advantage of the MOSes. They use very little power. And this isn't a stress test like an MSI combustor test or furmark. And I need to do that, but first I actually need to replace the fuses. It's something I really miss from the old cards, especially Sapphire ones. The new cards don't even have a fuse. They consume like 400, 500 watts without fuses. And when there's a short, who knows whether the GPU is going to survive or not. So let me grab some new fuses. Okay, I found them. I'm going to use hot air to remove the blown fuses. The solder is molten, but since this is a power plane, there are a lot of copper under the pads. That's why it takes some time to solder on the pads to melt. Let's get rid of them completely. I believe these are 10 amp fuses, as far as I remember. I'm going to change them with 10 amp fuses. This shouldn't be a problem. Put them away. We need yeah, 3 new ones. Let's see. I'm going to apply some solder beforehand. Let's grab one. Yeah. Just like that. And I'm going to apply some hot air. After the legs are connected, so it doesn't blow away the fuse. Yeah, it sits beautifully in its place. Let's apply some solder here also. Okay. Let's grab our fuses. Here we go. I'm going to just solder one of the legs and let hot air do its job. They're going to just sit in their places because of the surface tension, the liquids. Yeah, it just goes in its place. Okay, this should be it. Let's check for any shorts again on the 12-volt rails before the fuse. Yeah, we see a voltage drop around 450, totally normal. From here before the fuse, yeah, voltage drop, and it's the same as after the fuse. So this card looks alright. I thought the controller was bad. That's why I thought two of the MOSFETs, two of the DR MOSFETs actually were blown. But after someone butchered this card, this looks alright. I'm shocked, actually. I'm going to clean the card, reassemble it, and test it under heavy load, because I don't still believe that this card is not going to blow these MOSFETs, these DR MOSFETs again. I'm not sure. But I have hope. That's why I'm going to clean before reassembling it. And if I see any problems, I'm going to continue the video. But if there's not, then the video ends here. Thank you for watching. I hope you enjoyed it and learned something new. Please comment down below if you have any questions or any suggestions. Thanks for watching. See you later.